Alright, Chapter 2, Layout and Fabrication of Sheet Metal and Fiberglass Duct. As a steel worker, you're required to operate sheet metal tools to apply basic sheet metal layout techniques in many naval construction force projects. Sheet metal is used to protect the exterior building from flashing gunners. At times, complete sheet metal roof systems. Other items may be made from sheet metal are dust collection system, machinery, guards, locker, and shelving. Although many of the parts and fittings used in the sheet metal work are stock items which simply install with assembled steel workers are required to fabricate parts fittings frequently in the shop or to modify them in irregularities of project design. Therefore, you must have knowledge not only in laying out patterns but also have skills required to cut, bend, shape, assemble, install the finished sheet metal products. The chapter describes some of the methods measuring, marking, cutting, forming, joining, as well as installing sheet metal section duct system fiberglass ducts, in addition to the various hand tools and power tools required in sheet metal layout fabrication is provided. Sheet metal layout cutting tools and equipment numbers, types of layout and cutting tools, forming equipment used with working sheet metal. The section describes the use of the layout and cutting tools, operation, forming equipment, layout tools, layout of the metal procedure, measure, marking, material, and cutting, drilling, or welding accuracy. Essentially, layout work of the erroneous material result in a product being fabricated that does not fit in the overall job. This is the waste of both material and time. In most cases, you should use shop drawing sketches, blueprints to obtain measurements required to fabricate the job being laid out. Your ability to read work for blueprints and sketches is paramount to layout work. If you require information on blueprints, you will find it in Chapter 1, 3, and 8. Blue Reading Sketching NAVEDTRA1425151. Excellent reference. Layout tools are used in layout fabrication jobs on metal. Some more common layout tools that you will use performing layout duties are as follows: a scriber, flat steel square, combination square, protractor, prick punch, divider, trammel points, and circumference rule. Your scriber lines are scribed on sheet metal scratch AWL coupled with a steel scale or a straight edge to obtain the best results. Scribing hold the scale straight edge in place and set at the point of the scriber closest to the edge of the scale as possible by tilting the scriber outward. Then exert point on the draw and draw the line, tilting the tool slightly direction of movement shown figure 2.1. For short lines, use a steel scale as guide. For longer lines, use a circumference ruler or a straight edge. When you have to draw a line between 2 points, prick punch each point, and then start the one prick punch mark and scribe toward the other. Figure 2.1 shows scribing the line. Complete the line scribing the other prick punch mark on the opposite direction. Flat steel square. The flat steel square is desired tool construction perpendicular, parallel in the method of layout known as parallel line development. Flat steel square is used to construct lines that are parallel to each other as well as perpendicular to the baseline. This is particular procedure is shown in figure 2.2. Simply clamp the straight edge firmly to the baseline. Simply slide the body of the square along the straight edge. Then draw perpendicular lines through the desired points. Before using a flat steel square, at least periodic intervals depending on use to see what you check your accuracy is shown in figure 2.3. When the square is off, your work will be off corresponding no matter how careful you are. Combination square can be used. Draw a similar set of lines shown in figure 2.4. An edge of metal upon which you're working on is the baseline shown in figure 1. Edge head of the combination is 90 degrees and the other is 45 degrees. Combination squares are delicate instruments of little value. Handle them roughly. Store squares properly. When you're finished with them, keep the clean tip-top shape. You will be able to construct 90-degree angles, 45-degree angles, and parallel lines without error. Figure 2.2 shows using construct perpendicular or parallel lines. Using a check a square for accuracy, tongue, body, double error, double the error. Figure 2.4 shows a combination square. Protractor to construct angles other than 45 degrees, 90 degrees. You will need a protractor. Mark the vertex of the angle with your baseline with a prick punch. Set the vertex on the protractor on the mark, then scribe a V to the desired angle. Assume 700. Scribe the line between the vertex and the point located in the V. You have constructed an angle of 70 degrees. The prick punch. When you locate a punch or mark it with a prick punch, you will be using the line of tap with a small beam pan hammer. ensuring it is on a precise spot intended to mark. The smaller the mark we make, so long as it is visible, the more accurate the mark becomes. Dividers. When you should use the divider, scribe, arc, circles, transfer measurement, scale to your layout, transfer measurement from one part of layout to the other. Careful setting of the dividers is of utmost importance when you transfer a measurement from a scale to works at one point of the dividers. Mark carefully, adjust the other leg, required length shown in figure 2.5. Scribe a circle and arc, grasp the dividers between the fingers and thumb as shown in figure 2.6. Place the point one leg on the center. Swing the arc and exert enough pressure to hold the point onto the center slightly and decline dividers in the direction in which they are being rotated. Alright, trammel points. Describe a circle with a radius large with the divider shows as select trammel points. The method adjusting points shown in figure 2.7 is set with the left hand point on the one marker, slide the right hand point on the required distance, tighten the thumb screw. The arc or circle is inscribed in the manner as the dividers. Construct a 90-degree right angle is not difficult if you have true steel squares. Suppose that you don't have a square that your square is off, or you need a right angle for layout, but break out the dividers, a scribe, and a straight edge. Draw a baseline from one labeled AB. Select the dividers in distance greater than 1/2 the AB. Then with the A center, scribe the arcs like labeled C and D. Next, without changing the setting of the dividers, use B as center. Scribe another set point of arcs from at C and D. Draw a line through the points where the arc intersect. You have directed perpendicular lines at AB forming 90 degrees or right angles. You have also bisected the divided line AB into two equal parts. Construct a right angle at given point with the part of the dividers and procedure you will find useful making layouts. Figure 2.9 shows the method of constructing a right angle at the point. So 2.5 shows the setting of the dividers, scribing a circle with the dividers. 2.7 shows setting trammel point set at 12-inch radius, left-hand trammel. Constructing a 90-degree angle, bisecting a line. Constructing a 90-degree angle at a given point. Imagine you have a line XY as the point with which fabricate the perpendicular form of a right angle. Select the convenient point of the lies somewhere within the proposed 90-degree angle. On the point using C, use the center of the circle with a radius equal to CA. Scribe the semicircle arc as shown. Lay the straight edge along points B and C. Draw a line intersect the other end of the arc D. Next, draw a line connecting points D and A. You fabricated a 90-degree angle. This procedure may be used to form a 90-degree angle, 90-degree corners, and sketch layouts as squares and rectangles like dripping pan or a box. Lay out a dripping pan with a pair of the dividers no more difficult fabricating perpendicular. You will need a divider, scribe, straight edge sheet of the template paper. Here with the dimension point of the be fabricated length, width, height of the depth. Draw a baseline, select a point on the line with the corner of the drip point layout. Write a perpendicular through this point, forming a 90-degree angle. Next, measure off the baseline required length of the pan at the point. Erect another perpendicular. You now have 3 slides of the stretch out using the required width of the pan for other dimensions. Draw a 4-side parallel to the baseline, connecting the 2 perpendiculars for the fabricated. Now set the dividers, marking the depth of the drip pan. You steal the scale with the measure off the correct radius for the dividers. Use each corner of a point. Swing the arc like as shown from the second step. Extend to the end of the side of the shown figure. The last step, do to 110, and complete the sketch layout connecting the arcs within the scribed straight edge. Bisecting an arc, another geometric construction. You should be familiar with the angle of ABC. Figure 2.11 is given. And with B in the center, draw an arc cutting the angle D and E. With the D and E as center radius greater than half the arc of the DE. Draw the arc intersecting F line through B through point F, bisecting angle of ABC. 2 methods use the divided line into the given number equal parts shown in figure 8212. When the method is shown in view A, it is to be used, you will need a straight edge dividers. In using this method, draw a line AB desired length with the divider set at any given radius at point A as the center. Scribe an arc above the line using the same radius B as center. Scribe arc below the line as shown from. Alright, shows 2.10 shows laying out a drip pan with the dividers. Give the length and the 90-degree angle, and then you took the radius on the corners, and then you collected the layout with the drip pan dividers, bisect the angle, figure 212. 2 methods dividing lines into equal parts as 212. At point A, draw a straight line tangent arc that is below B, and do the same with the point B with the dividers. Given the distance, start point A, step off with the required number of spaces along line D, AD. Using tick marks in this case, number of tick marks are shown. Do the same with the B along line BC. With this ready to draw lines from point 6 to point A, 5 to 1, 4 to 2, 3 to 3, 2 to 4, 1 to 5, and B. For the 6, you should have the divided AB and the 6 equals part. With a method shown in view B, figure 212, you the divided line, give it the number equal parts. You'll need a scale. You with the method, draw a line, right angles, one end of the baseline, place the scale each side such angle with the number of spaces required, divided evenly into spaces covered in the scale. Illustration view B, figure 212, baselines 2.5 inches divided into 6 equal parts. To place the scale so the 3 inches will cover 2.5 inches on the baseline. Since the 3 inches divided into 6 spaces half inch, draw lines from half-inch spaces in the same scale perpendicular to baseline. Identically, you may use a full 6 inches in the scale by increasing angle slope for the using baseline, dropping perpendiculars from full inch graduation of the baseline. Divide the step-off circumference circles of a circle into 6 equal parts. Just dividers, radius, circle. Select the point on circumference. Begin point A, selected beginning point A, which A is the center. Swing the arc through the circumference of the circle like a one point shown in B illustration. Use B, then point S, swing the arc through a circumference C. Continue to step off of the spanner until you have the divided circle 6 equal parts. Points for the intersecting points arc of the circumference connected, shown in figure 213. Lines will intersect the center of the circles, forming angles at 60 degrees. If you need an angle of 30 degrees, all you have to do is bisect one of the 60-degree angles by the method described earlier in this chapter. Bisect with a 30-degree angle, you have the 15-degree angle. You can construct a 45-degree angle with the same manner, bisecting a 90-degree angle, and in all probability you have the protractor layout of the other angles. But just in case you don't have a steel square or protractor, it's a good idea to know how to construct the angles various of the erect perpendiculars. Many times our laying out work with a circular and arcs necessary to determine the circumference of the circular arc if there are applicable mathematical formula for appendix 2 of this text. Circumference rule. Another method of determining circumference is the use of the circumference rule. Operated circumference rule graduated in inches in the same manner as regular scale out, but the layer is edge is graduated, shown in figure 214. Lower edge give the approximate circumference of any of the circle ranging from the rule. Will notice figure 214 that reading the lower edge directly below the 3-inch mark, little over 9 3/8 of an inch. This is figure 213 shows the dividing into 6 parts. Figure 214 shows the circumferential ruler. Reading wood circumferential circle, the diameter 3-inch would be the length of the sketch out of the cylinder with the diameter and dimensions. Sketch out cylinder object through the height of the cylinder and the circumference. Cutting tools. Various types of hand snipping, hand sheared, are used in cutting, notching sheet metal. Hand snips are necessary because of the shape, construction, location, position of the work to be cut. Frequently prevents use of the machine and cutting tools. Hand snips are divided into 2 groups. Those straight cuts or follow straight snips, combination snips, bulldog snips, compound lever shears. Those circular cuts are followed with the circle, hawk, bills, aviation, Trojan snips. These snips are shown in figure 215. Following is a brief description of each type of snips. Your straight snips are to figure 215 view A, have the straight jaw, straight line cutting to ensure the strength that are not pointed. These snips are made in various sizes. Jaws may vary from 2 to 4.5 inches. Overall length will also vary from 7 to 15 3/4 of an inch. Different size snips are made to cut different thicknesses of metal. 18 gauge steel as minimum with large snips. These snips are available in the right and left hand. Use combination snips. Figure 215 view B have straight jaws, straight cutting of the interfaces of the jaws or slope the cutting force curves as well as irregular shapes. These snips are available in the same size and capacity as straight snips. Bulldog snips, figure 215 view C, are the combination type. They are short cutting blades with loop handles of the leverage. The blades are inlaid with special alloy steel cutting stainless steel. Bulldog snips are cut 16 gauge mild steel. The blades are 2.5 inches long. Overall length of snip varies from 14 to 17 inches. Compound lever shears, figure 215 view D, how they have levers designed to give additional leverage. Use cutting heavier material lower blade and allow the shears to insert in a hole with a bench or bench plate. This will hold the shear in an upright position, making the cutting easier. If the cutting blades are removable, can be replaced. capacity of 12 gauge mild steel. It has the cutting blades. They're 4 inches long, overall length of 34.5 inches. Circular snips, figure 215 view E. Curved blades are used for making circular cuts of the name and play with a common size shape. Capacity straight snips, either right or left hand is available. Hawk bill shape snips, figure 215 view F, are used to the cut small radius inside outside. Circle with narrow curved blades are beveled to allow sharp turns without buckling sheet metal. These snips are used for the cutting holes in the pipe to furnace hoods, closed quarters work. These snips are available in 2.5-inch cutting edge, has an overall length of 11.5 to 13 inches, or have 20 gauge mild steel capacity. Aviation snips, figure 215 view G, have compound levers that enable them to cut less effort. The snips have the hardened blades that enable them to cut hard material. They are useful for cutting circle, cutting squares, and cutting compound curve with intricate designs in sheet metal. Aviation snips come in 3 types: right hand, left hand, and straight. On the right hand snips, the blade is on the left and they will cut to the left. Left hand snips are the opposite. They usually are color coded to keep it in the industry. Standard green cuts right, red cuts left, and yellow cuts straight. Both snips can be used as a right hand, and both snips can be used with the right hand. These snips are 10 inches long and have 2 inches cut and have a 16-inch gauge mild steel. Trojan snips, figure 215 view H, are slim-bladed snips so that you use the straight and curved cutting. The blades are small enough to allow sharp turning cuttings without buckling the metal. These snips can be used to cut outside curves that can also be used to place encircle snips. Hog bill snips are aviation snips with cutting inside curve. The blades are forged with high-grade steel. These snips cut in 2 pieces, one over the 2.5-inch cutting length and the 12-inch overall length, and the other has a 3-inch cutting length and a 12-inch overall length that both have a 20-gauge capacity. Modern snips are designed to cut freely, minimum curling of the method. Snips are generally held in the right hand with the right angles. Work with figure 216. Open the blades widely and obtain maximum leverage. Do not permit the ends of the close completely to the end of the cut or rough. Alright, figure A shows your straight snips. Figure B shows a combination snip. Figure C shows the bulldog snip. And then figure D, a compound snip, lever snip. Figure E is a circular snip. F is a hawk bill bill snip. G, aviation snips. And H, Trojan snips. 216 shows the proper method of cutting with snips. In the edge result circular cut section, right side, figure 217, when making internal circular cuts, make your small opening near the center of the opening, encircle the snips, and cut the upper side. Gradually increase the radius of the cut until the opening is completed. In figure 218, large metal sheet metal sections of squaring shears discussed later in this chapter. Combination notcher, coper, and shear, figure 219. Ideal notching corners, edge of sheet metal blades are adjustable, conventional notching, piercing, starting inside the blank. Portable power shears are made possible to production work. They are designed to do straight circular cutting, figure 220. Small diameter openings are made with a hole solid punch, figure 221, hollow punch. So it shows making a circular cut, and then also shows making an internal circular cut. Section to be removed, path of the snips, a hole made with a hole punch. Figure 219 shows a combination notcher and coper shear. Alright, locate the position of the hole, select with the correct size of the punch and hammer, place the metal section on the lead cake, edge grain of the block of hard wood, strike the punch firmly within the hammer, turn punch section over the bird section up, smooth it with a mallet. Footed action squaring shear, figure 224. We'll show figure 20 shows a portable power shear. Figure 221 shows a solid punch. Figure 222 shows a hollow punch. Alright, and figure 223 shows a correct method of backing sheet metal with making a hole punch. Correct. Lead cake, end grain, indented, end grain, incorrect. Foot actuated squaring. Shears figure 224 makes it possible for the square and trim large sheets. Do not attempt to cut metal heavier than the design capacity of the shears. Maximum capacity of the machine is stamped on the manufacturer's specification of the front of the shears. Check with the gauge metal against the size of the sheet metal gauge. Figure 225. This figure showing the gauge is a disc-shaped piece of the metal having slots width with the corresponding US gauge number 0 to 36. Each gauge number is marked on the front of the corresponding decimal equivalent on the back. Do not cut wire, band, iron, steel rods with a square shear. Alright, shows the foot actuated shearing, square shearing, extension arms, front gauge, side gauge, hold down gauge, back gauge, bevel gauge, foot pedal. Figure 225 shows the sheet metal gauge, thickness in sheets. The length of the cut is determined by the position on back gauge metal is inserted with the front of the shear of the front gauge. Control of the length of the cut with the metal sheet inserted from the rear. Front gauge is seldom used, usually removed from the shears. A bevel gauge permits angular cuts to be made. To make a cut with a back gauge, require the dimension of the graduated scale on the top of the extension arm of the graduated section on the bed top. Hold the piece firmly against the side gauge with both hands with the hold down when it comes into position. Apply the pressure of the foot pedal. Note, keep hands clear of the blade and feet beneath the foot pedal. Ring and circular shears are the intent of the cutting inside-outside circles. Metal with the clamp holding clamp head position from the desired diameter. Blank inserted lower cutting disc and make the cut. Sheet metal bending and forming equipment. Sheet metal is given the three-dimensional shape of the rigidity by bending. Sheet metal can be formed by the hand with the various special tools and machine. Several techniques are described in the following sections. Figure 226 shows the ring circular shears, stakes. Metal stakes allow sheet metal craftsmen to make an assortment of the bends by hand. Stakes come in a variety of shapes and sizes. They worked on its head and horns of the stakes. They are machine polished, in some cases hardened. Stakes are used to finishing many types of work, therefore they should not be used to back up the work when using a chisel. The following is an assortment of the most common stakes used in the Navy Construction Force and Public Works Division Department. 1. Square stake, figure 26 and 27 of view A, have the square-shaped head with the use of the general work. These three types use coppersmith square stakes, open-ended, rounded, bevel-edged square stake, that is offset, common square stake. Some of the edges are beveled. This allows us to use the greater variety of edges. 2. Conductor stake, figure 227 of view B, a cylindrical horn, diameters is used when forming, seaming, riveting pieces, parts, and pipes. 3. The hollow mandrel stake, figures 27 view C, slot which both slides allowing to clamp firmly into the bench, either rounded or flat end of the used forming, seaming, riveting. There are two sizes available. The overall length of 40 and 60 inches. Blowhorn stake, figure 27 in view D, with the two horn different taper to the apron is used with the forming shape, blunt, tapered, slendering, tapered end is used, slightly tapered job. 5. Brake horn stake, figure 2027 in view E, is a general purpose stake with the stake has a round tapered horn on one end and square tapered horn on the other. The stake is used with the riveting and shape around of the square work. 6. The double seaming stake with the 4 interchangeable heads. View F has 2 shanks. Either one can be installed, and then it shows. We'll look at the stakes. Now we have a copper square stake, a bevel edged square stake, a common square stake, the horn or conductor stake, the hollow mandrel stake, the blowhorn stake, the beak horn stake. Alright, the double heading seaming stake with 4 heads and the metal stakes. And the bench plate allowing the stakes to use the vertical with a horizontal stake with you for the double seaming, the large work and all riveting. A hand dolly, figure 227 of view G, is a portable anvil handle used for backing up rivet heads, double seams, and straightening. So that's your hand dolly right there. Other forming tools. Stakes are designed to fit bench plate, figure 228 bench plate with a cast iron plate that is affixed to the bench with a tapered hole with a different size of support with the various stakes that can be used within the plate. Additionally, there is another type of the bench plate with the revolving plate with a different size which can be clamped in any of the desired positions. Setting hammer figure 229 has a square flat face peen and single tapered peen set down on the edge face U of the flat seam. Setting hammers varying in size from 4 ounces to 20 ounces. Use is determined by the gauge of the metal and accessibility of the work. Wood mallet figure 230 shows provides a necessary force of forming sheet metal without marring the surface of the metal. Narrow sections formed with a hand seamer in figure 231 primarily used for turning flange, bending an edge, folding a seam. This wedge and width of the flange can be set with the kernel knobs or top of the jaw. Figure 228 shows a bench plate. Figure 229 shows the setting hammer, peen head, check face, handle. Figure 20 shows a wooden mallet. Figure 231 shows a hand seamer. Forming and bending machines. Many machines have been designed to perform precise sheet metal operations that include bar folders, shovel type, the brakes, roll forming machines, combination rotary machines. These machines are described before. Next, your bar folder, the bar figure folder 232 with a design to bend sheet metal, generally 22 gauge or lighter. The bar folders are either the bending edges or sheet at various angles, making channel shapes, double and right angle folds, fabricating lock seam, wire edges. Narrow channel shapes can be formed. Reverse bends cannot be bent at close distances. Width of the folder edge determined by setting of the depth gauge. Figure 233. Sharpness of folded edge, whether it be sharp at the hem and seam with a rounded to make wire edges, determined by the position of the wing. Figure 234. Right angle 90 degrees. 45 degree bends can be made by using a 90 degree and 45 degree angle stop. Hemmed edges are made with the following manual 235. Adjust the depth of the gauge required to the size, position of the wing with the desired folded sharpness. Set the metal in place, sitting lightly against the gauge fingers, and it shows 3 with the left hand holding the metal. Pull the handle as far as will go. Pull the handle until the original position. 4. Place the folding section, beveled section of the blade as close to the wings as possible. Flatten and fold the pulling handle forward rapidly. Alright, 232 shows the bar folder, and then 233 shows the folded size, depth gauge, indicator scale with the measuring depth of the fold, adjusting knob. 234 wing setting, determine tightness, fold, bar folder, wing, and then it shows making the hem edges. Alright, brakes are large sheet metal sections formed by either the bending brake. These machines produce more uniform bends that can be made with a hand, required significantly less effort. The two most commonly used the brakes are corners brake and a finger brake. Corners brake, shown in figure 226, due adjustment have been made by using the machine. One adjust the upper jaw of the clamp of the bar vertically on the gauge. Sheet metal to bend and the clamp of the bell device over the board works slightly in position, provided with the correctly adjusted. For example, if the clamping device is set 18 sheet metal gauge, shift the Cornelius brake, balancing weight, clamping bar handles, upper jaw clamping, bending left handle, bending leaf, holes and mold clamps, rod yoke, and stop. Bend 24 gauge sheet metal is setting sheet metal slip at the bend with a form wrong position when you try to bend an 18 gauge sheet metal. When you machine is set for 24 gauge sheet metal, you can break the clamp bar handle. Pressure must lock it with clamping bars will never be too strong. With little practice, you will be able to gauge pressure correctly. Adjust the upper jaw horizontally to correct the position, thickness of the metal, the radius bend to be made. Caution: if you have an upper jaw, adjust the exact thickness of the metal. The bend will sharpen it or will have practical no bend radius. If set more than thickness of the metal, the bend will have the large radius. The jaw of set for less than thickness of the metal. Jaw of the machine may sprung out of the alignment. The edge of the jaws may be damaged. After these two adjustments have been made, the machine is operated to valve, describe the line of the sheet metal with the show of the bending will be to raise the upper jaw of the clamp handle to insert the sheet with the brake and bringing the scribed line in position even with the front edge of the upper jaw. 3. Clamp the position sheet metal in position, ensure that the scribed line even with the front edge of the upper jaw. Locking motion will occasionally shift the workpiece. Once you've satisfied with the metal clamp correctly, next step of lifting, bending the leaf, the required angle to form the bend. If the bend soft, the ductile matters such as copper, The bend will be formed at an exact angle raised from the bending leaf. If you're bending metal that has any spring to it, you will have to raise the bending leaf a few degrees more to compensate for the spring in the metal. The exact amount of spring that you will have will allow you for it depends on the type of the metal you are working with. 5. Release the clamp handle, remove the sheet from the brake. The brake is equipped with a stop gauge, consists of the rod yoke with a set screw that you can use the top bending leaf at the required angle. This feature useful to have to fabricate large number of pieces the same angle. If you have made the first bend required angle, set the stop gauge bending leaf with not going beyond the required angle. You can now fabricate as many bends as you need. Cornius brake is extremely useful in making single hems, double hems, box seams, various other shapes. It is impossible to bend all 4 sides of the box conventional brake. The finger brake, sometimes referred to as the box pan brake, figure 237, has been designed to handle exact situation. Upper jaw is made up with a number of blocks referred to as fingers. Various widths can easily be positioned to remove all the 4 sides of the box to be bent, other than features operated in the same manner as a Cornius brake. Alright, roll forming machine. When a cylinder's column shower is being formed, sharp bends are obviously required instead of the gradual curve of the form of the metal units at the end of the meat. The rolling form machines have been invented to accomplish this task. Simple method of the forming these shape of the slip roll forming machine, figure 238. 3 rolls do the forming, figure 239. The 2 front rolls are fed rolls and can be adjusted to accommodate various thicknesses of the metal. The roll and adjustable gives the section the desired curve of the top roll. Pivots up permits someone to remove without danger of the distortion grooves are machined into bottom. Alright, figure 237 shows a finger brake, and figure 238 shows a slip roll forming machine. And then figure 239 shows the forming cylinders on the rolling forms, the starting position, the curvature controlled by moving the rear down, up and down. Rolls from the purpose of accommodating wire edge while forming the section type of the edge of the rolling wire into a ring combination rotary machine. Preparing sheet metal wire edge, turning a burr, bedding, the cramping of the probably the most difficult sheet metal forming operation to perform when production dictates. Large shops will have the machine for each operation. However, the combination rotary machine, figure 240, with a selection of rolls will prove acceptable to most shop use. Wire edge must be applied with tapered shapes after they have been formed. This is accomplished by turning the edge of the rotary machine, gradually lowering upper roll until the groove is large enough for a wire. The edge is pressed around with a wire for the rotary machine, figure 241. Wire edge can be finished by hand by a rotary machine. Is not available. The edge is formed on the Alright, 240 shows a combination rotary machine with extra forming rolls. Then it shows the upper roll, sheet metal, and gauge, lower roll, and then turning a wire edge rotary machine. The wire edge can be finished by the rotary machine or not available. The edge is formed by the bar fold of the form placed around the wire with the setting hammer and applied, figure 242. Turning a burr. A burr is a sheet metal ring with a narrow flange turned on a circular section end of the cylinder, figure 243. Before you cut the section, remember the additional material must be added as basic dimension object for the burr. Figure 244 shows how to calculate additional material. After the rotary machine has been adjusted by turning the proper side of the burr, the work is placed in position, upper roll lowered. Make one complete revolution piece, scoring the edge lightly, lower the upper right and roll a bit more, creating more pressure, making another turn. Continue this operation, raising the disc slightly. Each of the turn under the burr is turned over the required angle of 245. The procedure, you would turn the burr on the bottom of the cylinder, double seam, figure 246. 2 pieces snapped together. Burr set down, seam completed, figure 247. Note, because turning a burr is difficult, the operation should turn several practice pieces too. Figure 241. 4 shows setting a wire with the setting of the hammer, edge, pliers. Shows burrs turn in a cylindrical section. Shows the calculating material needed for the double heading, doubling for a double seam. Turning the burr edge, and then shows fitting the burrs together. Develop your skill before turning the burr on the actual pieces of used. Figure 240 shows over the double seam of cylindrical shape. A, B, C, and D. Bedding. Figure 248 is used to give it the added stiffness cylindrical sheet metal object. The decorative purpose of it can be simple beaded OG S-shaped bead. They are made over the rotary machine using beading rolls. Crimping. Crimping figure 249 reduces the diameter cylindrical shape, allowing it to be slipped to the next section. Eliminates need for each cylinder with a slight taper. Figure 248 shows the turning the bead with a rotary machine, single bead, and OG bead. Figure 249 shows the crimp section of the bead and the crimp. Sheet metal development. In sheet metal development work, some of the fabrication repair jobs can be laid out directly on the sheet metal development, proceed with done scratching. Usually the object to be made with required little or no duplication. Single part with the reduce the quantity of the different development procedures viewed instead of laying out directly on the metal. You will develop a pattern or template of the piece of the fabricated or the frame for the development to the metal sheet. Second development procedure is white. We primarily concerned within the section special attention given to three primary procedures commonly with developing sheet metal patterns. Their parallel line, radial line, triangular dividement. We also discuss the fabrication of edge joint seams and notches. Parallel line development. Development is based usually on the fact that the line with a parallel to another line equal the distance horn. That line at all points once have the opposite lines parallel to each other that have the same cross line section shape. Through their length are developed by this method. To gain clear understanding of the parallel line method, develop step-by-step layout. Trunicated cylinder figure 250. Such a piece can be used. Figure 50 shows the trunicated cylinder as one half of the two pieces owed 0 degree elbow. This may be the sheet metal to develop the following procedure. One first front draw a front and bottom view of the orthographic projection. Figure 251A, divide half the circumference of the circle view A into a number of equal parts showing the method of the straight line drawing the development layout between the division points approximate length of the arc of the projection. Leaving these points view is shown in figure 251 view B, resulting parallel lines for your front view of the area called elements. Layout of the baseline called the stretch outline. Development of the right front view, figure 251 view C. And then you have view A, bottom elements, and then you have stretch out length. And now we have the development of the trunicated cylinder. By the stretch out line into the twice of the number of the equal parts equal to each of the division circumference of half of the circle of the orthographic view, view C. Red perpendicular lines at each point shown in figure 251 view C with the Z-square straight edge projects the length of the element of the front view with the development of figure 251 view D. Use the curve, French curve, or other type to join with the resulting points at the intersection. Smooth the curve when the development is finished. Add necessary allowance for warrants and joints that cut your patterns. Radial line development. Radial line method of pattern development. You will develop patterns of the object with the tampering forms of the line converging with a common term of the radial line method, similar to some of them respect. The parallel line method of evenly spaced with the reference line necessary for both of these methods, but in parallel line development, the reference lines are parallel, like picket fence, and radial line development, the reference line radiates from the apex of the cone, like the spokes of the wheel. The reference line in the parallel development place. Project horizontal, the radial line of development, the reference line with the transfer into the front view, the development with the dividers. Developing a pattern frustrum of the right cone with a typical practice of the project, helping you with the feel of the radial line method. Familiar with the shape of the cone. A right cone is one that is set with a big side down on a flash with the wood straight up, and another wood center line drawn from the point of the vertex. The baseline would form the right angles with the line frustrating cone with the part of the remains at the point. Top head remember the procedure for the development of frustrating right of the cone given below. For the check each step of the procedure given the development shown figure 252. Draw a cone ABC with the line ED cutting the cone in such a way that the ED is parallel to the baseline BC. ED CB is called the frustrum in the center O with the radius OB with the draw of the half of the pan beneath the drawing line baseline BC. Divide half of the pan equal to the number of parts number that is shown. 3 with the vertexes A center of the divider 7 with the equal to AC. They draw the arc from the sketch. Bottom of the cone 4 7 of the dividers equal to the distance of the step off the half of the plane. Step off the twice by many speeds of the arc of the half of the plane. Number of steps off 1 to 7 to 1. As shown in the illustration figure 252. Draw with the line connecting A with a point 1 with the end of each of the sketch out with the arc of 1 to 7 to 7 to 1. Equal the length of the circumference at the bottom of the cone. Now you with the A of the center step of the dividers along the AC with the length of the AD. Describe the arc through with the both of the lines drawing A to 1. The area enclosed with a large spiral arc of the number 1 pattern of the frustrum of the cone allowance of the seaming edging of the stretch of the arc complete. Triangular development. Triangular slow with the more difficult with the parallel line, radial line development much more prior, particularly with the more types of figures. Additional is only a method which if it develops the rat warp surfaces may be estimated in a development by triangulation. A piece of it is divided into series of triangles radial line of development. However, there is no one single apex for the triangles. The problem becomes with the finding with the true length of varying with oblique lines, usually done with the drawing a true length of the diagram. Example layout with the triangulation development, the transition piece, the step of the triangulation, warp transition piece, larger squared duct, small round duct shown figure 253. Steps are followed with the draw of the top of the front orthographic views. A253 divide circle. Top view number n equals space with the angle of division points AD to take up in the top part of view D253 to point A. Complete with the 1/4 of development and with a sense of the speed of the symmetrical remainder of the development that may be constructed even the lengths of the first part. It is difficult to keep the entire development particularly symmetrical with the built up of the small triangle. Therefore, it may check the overall symmetry of the construction perpendicular bisects of A, B, C, C, D, and DA. View E, figure 253, converging at point O. From point O, swing arcs that B or as arc A should pass through the numbered points. At arc B should pass through the lettered points. Fabrication of edge joints. Seams and notch for the number type of the edge joints and seam of the notches joined with sheet metal. We will discuss that most often used. Edges are formed with the enhance the appearance of the work, strengthen with these, eliminate with the cutting as for the raw edge, for the kind of edge for the eve of the job determined by the purpose of the side of the strength of the edge needed. A single hem edge is shown figure 254. The edge can be made within the width. The general with the heavier the metal, with the wider with the hem is made with the allowance of the hem is equal to width of W in figure 254. Alright, so here we goes. Issue of the triangle development transition piece. A double hem edge is used with the edge strength is needed when smooth with the edge from inside as well as the outside. As long as the double hem edge is twice as width. So it shows a single hem edge and a double hem edge. A wire edge is specified over the plane objects, ice cube tray, funnels, garbage pails, other articles formed with sheet metal. A fabricated wire edge strengthens, stiffens jobs, eliminates sharp edges, and allowance for the wire edge 2.5 times the diameter wire. For example, you have the wire with a diameter 1/8 inch, multiply 1/8 by 2.5. Your answer is 5/16, which will allow you to lay out sheet metal for the making of wire edges. Or 256 of the development of the truncated edge, and then 257 that show the making of a groove section seam joint. Figure 258 show the hand groover, and then 259 lock groove seam hand groover, and then 260 a cap seam strip seam, and B a locked corner seam. Groove seam joint, figure 257, to the most widely method of joint light and medium gauge steel with a two-fold edge locked together with a hand groover, figure 258, making groove seam on the cylinder with a fit piece for the stake with the locket with a hand groove that should be approximately 1/16 wider than the seam. Lock the seam, making the prick punch and then indentations 1.5 inch for the end of the seam. Cap the strip seam on view A, if often used as some of the air conditioned heating ducts, a variation joint lock corner. Seam view B, widely accepted for the assemble of rectangular shapes. Alright, a drive slip joins method 2, flat sections of the metal, figure 261 pattern of the drive slip with each of the notching dimension for the very application practice with lock seam with the edges. S joints are usually joined flat surface of metal with primarily U with the joint section with a rectangular duct with the air U with the joint panel with the air housing columns. Figure 262 show with a flat S joint with a view A pattern S cleat with a view B with a perspective view with the two pieces of metal form. The flat S joint with a view C with a note at the end of the finished S joint. Figure 263 show with a double S joint. View B with the pattern with a double S cleat. View A is one with the two pieces of metal. Note with the cross section on the particular form cleat, also cross section finished doubles S joint. His variation simple flat S joint does not require an overlap metals being joined, and shows driving slip pattern connections and a circular perspective S slip joint pattern. Figure 263 shows the double slip joint, S joint clear pattern. Alright, seams. Many kinds of seams are either joined sheet metal with sections. Typically, commonly, either seams are shown. Figure 265. Developing the pattern, ensure the adequate measure of the basic dimension of the make the seam with the fold of the made with the by hand. However, they are made much easier with a bar, hole, folder, or break. The joints are furnished by soldering and or riveting the developing sheet metal patterns. Ensure the add sufficient material with the base dimensions to make the seam. Several types of seams used to join the sheet metal section discussed in this section. There are three types of lap seam: the plain lap seam, the offset lap, and the corner lap seam. And the lap seams are joined, drilling or riveting by soldering, or both by riveting and soldering. To figure the allowance for the lap seam, you must first know the diameter of the rivet. Any plan to use the center of the rivet must be set in the form of the edge of the distance of 2.5 times the diameter. Therefore, the allowance must be 5 times the diameter of the rivet that you are using. Showing the procedure laying out the plain lap, the corner lap seam, and the rivets of the represents the diameter of the rivets. From the corner seams, allow all additional 1/16 of an inch of the clearance. Figure 264 shows a standing S cleat. Alright, 265 shows common sheet metal, lap seam, countersunk lap seam, outside lap seam, standing seam, flat lock seam, groove flat lock seam, lap bottom seam, insert bottom sleeve, single bolt bottom seam. Figure 260 shows lap seam, plain lap, offset lap, corner lap. Figure 265 shows the layout lap seam, riveting, and then 268 groove seams, and 269 Pittsburgh lock seam. Groove seams are used for the fabrication of cylindrical shape. There are two types of the groove seam: the outside groove seam and the inside of the groove seam. And the allowance of the groove seam and the time of the width of the lock, 1/2 of the amount of the edge of the each edge. For example, if you have the 1/4 inch groove seam, the 3 by 1/4 inch, 3 1/4 inch total allowance of the half, and half of 3/4 inch, 3/8 of inch allowance that you are at each edge. The Pittsburgh lock seam, figure 269, is a corner seam lock. Figure 269 shows the cross-section of the two pieces of the metal being joined cross-section thin and finished seam of the seams used with the lengthwise seam, the collar, square rectangular pipe, the elbow fitting of the deluxe for the seam that can be made with the break of the provided to be universal special forming. Machines have been designed and are available to appear with a quite complicated but lap and groove seam and consists of only two pieces of the two port with a flange single edge. And the pocket of the formula of the pocket is formed of the flange edge, insert the pocket with the extended edge of the turn over the insert edge complete of the lock. Method of assembly locking Pittsburgh seam is shown figure 270-271. The allowance of the pocket is width plus 3/16 of an inch width of the deposit of the pocket. The width of the flange edge must be less than W. For example, laying out a 1/4 inch Pittsburgh lock seam, your total allowance would be a 1/4 inch by 1/4 inch by 3/16 inch, or by 11/16 of an inch edge, which you are flaying out the pocket, and 3/16 of an inch flange edge. Alright, figure 270 shows the assembling the lock seam. 271 shows closing the lock seam, the flange part, and the pocketed part. 273 cross section standing seam. Hard standing seams are usually joined metal with extra stiffness needed, such as roof, the air housing, ducts, and so forth. Figure 273 cross-section finished standing seam dimension. Rivet spacing varying application. Standing seam use lafting required as follows: spreader, driver, cap, the pocket, slip, the government lock, and are seen frequently. Even the large duct construction stiffeners are required. Dovetail seam is usually the main length to join round pipe fitting flat sheet duct. The seams can be made watertight by soldering. Figure 275 shows pattern forming dovetail seams example, and it's used the notches. Notching is the last but not least important step that can be considered that you're going to be ready to lay out the job before you can mark it a notch. You'll have to lay out the pattern, add the seam laps or stiffening edge. If the patterns are not properly balanced, you will have trouble when you're starting the forming, assembly, finishing the job. Note: definite rule for the selecting a notch for the job can be given as soon as you can visualize the assembly of the job. You will not have any trouble determining the shape inside with the notch required. Alright, show the spreader, the X-Tack, solder, spreader, driver cap, rivets, pocket slip, government lock. This shows the dovetail lock seam. For the job, if the notch is to be made with the hole will be left with the finished job. If the notch is too small with the proper shape of the metal, overlap the bolt of the seam and the edge, but do not concern yourself with too much If your first notch does not come all as you would expect with practice experience, if it dictates size and shape, square notch is likely to first for the make with the kind of make you would lay out with a box and drip pan. You would eliminate surplus material with the top of the notches must be with the black corns. Look around the shop to see if how many different kinds of notches you can see in the sheet metal shapes. Slant notches are cut at 45-degree angle across the corner with a single hand with the meat at the 90-degree angle to show the steps in the form of a slant notch. The V-notch, even the seams in the end of the box, will also give the full V-notch when you have the construct of the bracket with the toe and flange. For similar construction, full V shown in figure 278. When you are making inside flange with an angle less than 90 degrees, you will have to use the modification full notch V-notch and get it flush joints to the angle of the notch. Depending upon the bend and angle of the modified V-notch is shown in figure 279. So you have figure 278 shows square notches, and then it shows slant notches. And 277, and then a V-notch, modified V-notch. A wire notch is not used with the wired edge of the depth of the edge of the pan, one wire with the diameter, more with the depth of the lines of the wire edge, 2.5 times the diameter. In other words, 3.5 times the diameter of the wire. Even the width of it is equal to 1 1/2 time of the width of the seam. The portion of the notch next time with the wire edges will be straight. Shape of the notch for the seam will depend on the type of the seam. You with the figure 280 of these 45-degree with the groove seam. Most of the work will require more than one type of notch on figure 280 with the wire notch. You with the forming a joint, a cylindrical shaped joint with the groove seam and the tough layout. You will have to notch the wire edge and seam. Joining and installing sheet metal duct, and we're going to cut the tapes there.